Okay, so hello and welcome back. So the next question that we have here is question number 3, which says basically find the equations of the lines which cut off intercepts on the axes whose sum and product are 1 and -6 respectively. So you have basically two lines and they cut off these intercepts on the axes. Their sum is 1. If the products, if the intercepts, I take them as A and B. A plus B is equal to 1, and A times B is equal to 6. I'm sorry, -6. So now this must have something to do with second degree equations or quadratic equations. I don't exactly know how, but this is just a very educated guess. Because you see, for example, when you have ax squared plus bx plus c is equal to 0. Let's suppose that, for example, a is equal to 1. Then you have x squared plus bx plus c is equal to 0. Then in this case, b is equal to, if I take the roots of this equation as alpha, and beta, b is going to be equal to alpha plus beta, and c is going to be equal to alpha beta. I don't really know if my guess is even close to, but there has to be some sort of relationship between this line over here, between this second degree equation over here, and basically ax plus by plus c is equal to 0. And in this case, we say that, for example, in this case, what we have is that we have two axes. So usually, for example, y is the vertical axis, and your y's are plotted across this vertical axis, and your x's are plotted across this horizontal axis. In this case, what we have is basically some, for example, when you have ax squared plus bx plus c, that is usually called, for example, f of x, which is also sometimes called y. And then your y is plotted across this axis, and your x's are plotted across the horizontal axis. Now, I want to take a look at the solution here and see if what I'm saying is actually, if there is any truth is in what I'm saying. So if you have miscellaneous exercises, Well, based on the solution that I see here, probably not, but there has to be some sort of relationship between these two equations, and that's something that I would really like to know or understand. But I suppose we will know more about these later, probably in, I don't know, probably in this book or the next book, or I don't know, some undergraduate course or some graduate course, something like that. But of course, it's not possible that there is no relationship between these two equations. It's simply not possible. Okay, so now about the solution about the solution for this example. So the question is basically find the equations of the lines. You want to find the equations of the lines which cut off intercepts on the axes whose sum and product are 1 and -6 respectively. So if that's the case, then if I take basically the two intercepts as A and B, then the sum is 1. That means that A plus B is equal to 1, and A times B is equal to -6. So you can of course solve this equation by, for example, you can write this as A is equal to 1 minus B, and then 1 minus B times B is equal to -6, or B minus B squared plus 6 is equal to 0. And so I can write -B squared plus B plus 6 is equal to 0, or I can write basically B squared minus B minus 6 is equal to 0. And so so now you're looking for two numbers, for example, let's call it, for example, A and B, such that A times B is equal to basically 1 times -6, which is equal to -6, and A plus B is equal to -1. There is a -1 over here. So -6 could be 2 times 3, and you could put a negative sign over here. And so 2 times -3 is equal to -6, 2 minus 3 is equal to -1. So you have these two numbers. So now you can use these two numbers to rewrite this equation, meaning that B squared minus 3B plus 2B minus 6 is equal to 0. And then you have B times, for example, B minus 3 plus 2 times B minus 3 is equal to 0, and B plus 2 times B minus 3 is equal to 0. Now what that means is that either B plus 2 is equal to 0 or B minus 3 is equal to 0. In this case, B is equal to -2, and this is B is equal to +3. And we said that for example, a times b is equal to negative 6. Now if b is equal to negative 2, a times b is equal to negative 6, that means that a times negative 2 is equal to negative 6, then you can simplify these two, and a is equal to 6 divided by 2, which is equal to 3. That's one case over here, and if b is equal to 3, then a times b is equal to negative 6. That means that a times 3 is equal to negative 6, and a is equal to negative 6 divided by 3, which is equal to negative 2. So that means that you either have a is equal to 3 and b is equal to negative 2, and or you have a is equal to negative 2 and b is equal to 3. These are the two cases that can exist in this situation. Now we know that our basically x coordinate is, I'm sorry, not the x coordinate, but the x-intercept is positive 3, for example, in this case, and the y-intercept is negative 2. So then you can write the equation of the line as x over a plus y over b is equal to 1, and so you can write x over 3 plus y over negative 2 is equal to 1. That is basically one equation. Or you can write basically x over negative 2 plus y over 3 is equal to 1. That is another equation. So then you can of course simplify these if you want to, and you can write this as multiply by negative 6, for example. You'll get negative 6x over 3 plus negative 6 over negative 2, negative 6y is equal to negative 6, and then there you would get actually you could have multiplied by a positive 6. So 6 divided by 3 is equal to 2x minus 3y is equal to negative 6, or you could write 2x minus 3y is equal to 6. So that's one equation that you could have. Or here you can multiply by 6 again, meaning that 6x over negative 2 plus 6y over 3 is equal to 1, is equal to 6. So 6 over negative 2 is equal to negative 3x, and over here you have plus 2y is equal to 6. So you have negative 3x plus 2y is equal to 6. So these are the two equations that you can get related to this line. But again, over here, this relationship is something that I've always been thinking about this, but I've never actually had the opportunity to know how this actually works. Let's see how. Hopefully in the near future. So the next question that we have is, what are the points on the y-axis whose distance from this line is 4 units? You know, what are the points? What are the points on the y-axis whose distance from the line whose distances from the line x divided by 3 plus y divided by 4 is equal to 1 is 4 units. Okay. Okay, so let's take a look at this situation first graphically, see what this is. So this line over here is basically 12x divided by 3 plus 12y divided by 4 is equal to 12. And that is 4x plus 3y is equal to 12. And then you can write 3y is equal to negative 4x plus 12, and y is equal to negative 4/3 x. Divide by 3, you'll get a 4. 12 divided by 3 is equal to 4. So that is your line, and this way I understand it much better, of course. Although this way you can graph it as well, meaning that you can say that this is your x-intercept and this is your y-intercept, 1, 2, 3, and 4, and then this becomes simply your line. And of course, if you do it the other way around, meaning that using this, you know that your y-intercept is 4, which is the same point, and then your slope is negative 4/3. So for 3 units of horizontal change, you have negative 4 units of vertical change. So for 3 units of horizontal change, you have negative 4 units of vertical change, which brings you here, which is basically the same thing. Now, what you need to do here, you want to know what are the points on the y-axis that whose distances from this line is 4 units. That means that we are not looking at we're not looking at perpendicular distance. I don't really understand the question. I need to probably take a look at the solution. Okay, so now I understand the question. So you see that basically over here, if I draw this properly, let me basically erase. So this is 3 and 4. So you see that over here, what happens if I draw 1, 2, 3 units here, and 1, 2, 3, and 4 units here, and if I draw a line between these 2 points, that is going to be basically this line over here, which is x divided by 3 plus y divided by 4 is equal to 1. Now, by distance here, what is meant is actually perpendicular distance. So now the perpendicular distance of some point on the y-axis from this line is supposed to be 4 units, meaning that some distance like so for example, this is 4 units over here. You can take a look at this over here just for some sort of approximation. And something like this, for example, some distance like this, or of course this is just approximation. And if I assume that, for example, this is the perpendicular line to from the y-axis to the line that we have, and if I suppose that this is 4 units, then this is going to be one of those points. And this could be also one of them, probably. So this is going to be the other point. Well, of course, again, approximation. So this is again a 90-degree angle. So this point and this point seems to be the points that we are looking for. Now we need to basically use analytical geometry in order to find the coordinates of these 2 points. Now the way that you can solve this problem is that let's assume that the point basically having a perpendicular distance of 4 units from from 1, and I call this 1 over here, from 1. Let's assume that the point having a perpendicular distance of 4 units from 1 is basically, since you're on the y-axis, of course your x coordinate is 0 and your y coordinate is, let's take it as let's take it as b, for example. Let's take that as b, for example. You could take anything over here, of course, but let's take it as b. And so this line over here, the line that we have over here, x over 3 plus y over 4 is equal to 1, which is basically the line number, which we call basically 1. You can write it as 12x divided by 3 plus 12y divided by 4 is equal to 12, and basically 4x plus 3y is equal to 12. So this is again the same thing as 1 over here, and so and of course you can write this as 4x plus 3y minus 12 is equal to 0. And so if you compare this to the general equation of a general line, I would say ax plus by plus c is equal to 0. If you compare these two together, you will get that you will have a is equal to 4, b is equal to 3, and c is equal to negative 12. Now you know that the perpendicular distance of x1 y1 from ax plus by plus c is equal to 0 is given by d, which is equal to the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. You already know that. So we know that this point that we defined over here this point that we defined over here, 0 comma b, has basically a distance of 4 units from this line over here. So I can write 4 is equal to the absolute value of a, which is equal to 4 times x1, which is equal to 0, plus b, which is equal to 3 times b plus c, which is equal to negative 12 over the square root of basically 4 squared plus 3 squared, which is equal to 16 plus 9. So this is equal to, so you can say that 4 is equal to the absolute value of 3b minus 12 over the square root of 25, which is equal to 5. So that means that 20 is equal to the absolute value of 3b minus 12. So if that is the case, then you can write 3b minus 12 is equal to plus or minus 20. That means that 3b minus 12 is equal to 20, or you can say that 3b minus 12 is equal to negative 20. Now you can solve these two equations and get basically 3b is equal to 20 plus 12, which is equal to 32, which means that b is equal to 32 divided by 3. And over here you can say that 3b is equal to negative 20 plus 12 which means that 3b is equal to negative 8. So that means that b is equal to negative 8/3. So the coordinates of the 2 points that we get are basically 0 comma 32/3 and 0 comma negative 8/3. So 32/3 is the same thing as 3 times 12 is equal to 36, 3 times 11 is equal to 33, it's 10.5 or so. 32 divided by 3 is equal to 10.6. So that's basically 0 comma 10.7. 0 comma 10.7 is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Somewhere over here. And negative 8/3 is equal to 2.8 or so. 2.6. So negative 2.61, 2, and 2.6, and that's the exact point that we predicted. So that is basically these are basically the 2 points that we can have whose distances from that line, or whose perpendicular distances from that line are exactly 4 units. So that is that. So the next question that we have is question number 5, which is find perpendicular distance from the origin to the line joining these 2 points. So the perpendicular distance from the origin just need some time to save. Okay, so the perpendicular distance from the origin, you have the perpendicular distance distance from the origin to the line joining the points cos theta, sin theta, cos theta, sin theta, and cos phi, sin phi. So okay, so now to solve this problem, we want to find the perpendicular distance from this point. Let me go over to the example that we had. Okay, so let me erase all of these things. Suppose we don't need them anymore. And okay, so basically you have a line and you have 2 points on this line, meaning that you have cos theta, sin theta, and cos phi, sin phi. These 2 points are on this line, and of course you know that basically if you want to write the equation of a line, y minus y1 is equal to m times x minus x1, and you know that m is equal to basically y2 minus y1 over x2 minus x1. So now I can write the slope over here as, for example, sin phi, for example, minus sin theta, sin phi minus sin theta, over cos phi minus cos theta. And so the equation of the line becomes, for example, I take this point over here as x1, y1. So then I can write y minus basically y1, which is equal to sin theta, is equal to this m, which is sin phi minus sin theta over cos phi minus cos theta times x minus x1, which is equal to cos theta. Now if you basically, to get rid of this in the denominator, you can multiply this equation by cos phi minus cos theta, which would be y times cos phi minus cos theta minus sin theta times cos phi minus cos theta is equal to basically sin phi minus sin theta times x minus cos theta times x minus cos theta. And then you can write this as y times cos phi minus cos theta minus sin theta times cos phi minus cos theta is equal to basically x times x times this, which is x times sine phi minus sine theta minus cos theta times sine phi minus sine theta. And of course I can take everything to the other side of the equation, meaning that I can write this as basically y. So first what I'm going to do is that I'm going to write this as y times cos phi minus cos theta, and then I'm going to multiply these. So minus sine theta cos phi plus sine theta cos theta. And then over here I'm going to write the same thing, x times sine phi minus sine theta. And over here I'm going to write minus cos theta sine phi plus cos theta sine theta. Now plus sine theta cos theta and sine theta cos theta can cancel out. And basically cos theta sine phi I have over here. Over here I have sine theta cos phi. So this is equal to if I take this to the other side of the equation, I can take this x to the other side. Meaning that I can write basically y times cos phi minus cos theta, and over here I have minus sine theta cos phi, and then over here I have plus cos theta sine phi, and then I have this x over here, which would be minus x times sine phi minus sine theta is equal to 0. So I have 1, 2, 3, 4 terms over here, and I have 1, 2, 3, and 4 terms over here. Now you can see that basically over here I have cos theta sine phi and sine theta cos phi. So if I multiply this by a negative 1, I will get negative y times cos phi minus cos theta plus sine theta cos phi minus cos theta sine phi plus x times sine phi minus sine theta is equal to 0. And I did this because you know that basically sine x minus y is equal to sine x cos y minus cos x sine y minus cos x sine y. So you can see that over here I can take theta as x and I can take phi as y, and you can see that I needed this to be a negative term over here so that I could use this formula. So now I can write this as so basically x, I can bring it over here, x times sine phi minus sine theta minus y times cos phi minus cos theta, and then these two terms over here I can write them as basically sine theta cos phi minus cos theta sine phi is equal to, I can write it as plus sine of theta minus phi. plus sine of theta minus phi. Or I can do it the other way around. Over here you can see that I can actually do it the other way around, and I'm doing it the other way around because I want my results to be in agreement with the signs that I can find in the solution, so that I can follow the solution. Otherwise I wouldn't do this. So now what I'm going to do is that I'm going to just erase all of this and use this as it is. I'm not going to multiply it by anything, meaning that there is still something wrong over here. X plus y so let me see what for whatever reason it's not really possible to understand what they have done in this solution, so I'm just going to do my own thing. So over here you see that I have sine theta cos phi, so sine theta cos phi and cos theta sine phi. So I can basically again do the same thing, meaning that I can write negative y times cos phi minus cos theta plus sine theta cos phi minus cos theta sine phi plus x times sine phi minus sine theta is equal to 0. And now I have basically sine theta cos phi minus cos theta sine phi, which is equal to sine theta minus phi. This becomes sine theta minus phi, and this becomes x times sine phi minus sine theta minus y times cos phi minus cos theta minus cos theta. And then over here I can write plus sine of theta minus phi. And I think we want to show the same thing over here. Or at least the solution over here is the same thing. Meaning that it is phi minus theta. Okay, so since it is phi minus theta, since I want to show the solution in terms of phi minus theta, so I'm going to not do this actually. See over here what I'm going to do. I apologize for this step, but I suppose I have to do this. So over here I can basically cos theta. So I can write this as basically this part over here, which is negative sine theta cos phi plus cos theta sine phi. So what I can do is that I can write it as basically sine phi. I can put this over here first, over here, bring it as the first term, so that would be sine phi cos theta minus cos phi sine theta, and you can see that sine x cos y minus cos x sine y is equal to sine of x minus y. So this would be sine of basically phi minus theta. So now I'm going to just write this as it is, meaning that I'm going to write this as negative x times sine phi minus sine theta plus y times cos phi minus cos theta plus sine of phi minus theta is equal to 0. Okay, so now basically everything is hopefully taken care of, and basically your a over here is basically the coefficient of x, which is equal to negative of sine phi minus sine theta, and your b is equal to cos phi minus cos theta, cos phi minus cos theta, and your c is equal to sine of phi minus theta, phi minus theta. And so what you want to do is, now you want to find the perpendicular distance from the origin to this line. So we said that d is equal to basically the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. So if that is the case, then since basically the distance is from the point 0, 0, then this becomes 0, this becomes 0, then your d becomes basically the absolute value of c over the square root of a squared plus b squared. Okay, and so you have basically c is basically sine of phi minus theta, so your d is equal to the absolute value of sine of phi minus theta, sine minus theta, and your denominator becomes the square root of a squared plus b squared. So it becomes sine phi minus sine theta whole squared, sine phi minus sine theta whole squared, plus b squared, which is basically cos phi minus cos theta, cos phi minus cos theta, cos phi minus cos theta whole squared. So that is going to be the distance, and then we need to make some changes, simplify this formula to get to the answer. And remember that you want to show that just to not do unnecessary things. You want to show that this distance is actually equal to the absolute value of sine phi minus theta. This is the right answer, okay? Because you might actually get any answer, and your answer might actually be right, but it might, the form of your answer might be different from the right answer that you can find in the book, and then you might get into trouble, meaning that you wouldn't know whether your answer was right or not. So you wanna try to basically express your expression in terms of the right answer that you can find in the book. That is basically a safe way to do this. And then of course it doesn't really matter in what sort of form you express your expression, as long as it's right in whatever form it's expressed, basically that is basically the right answer. And that way again you can make sure that your answer is right. So you want to write it as the absolute value of sine phi minus theta 2 times the absolute value of sine of basically phi minus theta divided by 2. This is the form that you want to get your expression in. This is the form that you want to get your expression in. Okay. So now you can simply expand these over here, meaning that you can write this as basically the absolute value of sine phi minus theta, and in the denominator you can write this as the square root of sine squared phi plus sine squared theta minus 2 times sine phi sine theta, and then over here you have cos squared phi plus cos squared theta minus 2 times cos phi cos theta, and you know what sort of thing I'm doing here. You already know your algebra, hopefully. Well, of course, you know what I'm doing here. It's simply a plus b whole squared is equal to a squared plus 2ab plus 2ab plus b squared, and a minus b whole squared is equal to a squared minus 2ab plus b squared. So that's what I'm doing here, this one. So then now you know that basically sine squared phi plus cos squared phi, that is equal to 1. So I can write this as basically the absolute value of sine phi minus theta, and sine squared phi plus cos squared phi is equal to 1, the square root of 1. Sine squared theta plus cos squared theta is equal to 1, so that's plus 1. And negative 2 times sine phi sine theta, negative 2 times cos phi cos theta, is something that we need to actually either we need to derive that, or you can also let me show you how to do that. So you know that basically you do know that let me see what I have over here. So if you have basically negative 2 times sine phi sine theta and negative 2 times sine phi, cos phi cos theta, so this is the same thing as well, okay, sine, okay, so let me see. Okay, so now to simplify this part, what you can do is that you can write this as basically negative 2 times sine phi sine theta plus basically cos phi cos theta. Okay, so you can write it this way, and you do know that basically well, cos x minus cos y, you do know that cos x minus cos y is equal to, cos x minus y. You know that cos of x minus y is equal to cos x cos y plus sin x sin y. And these are the same things, meaning that you have cos phi cos theta plus sin phi sin theta. So you can write this as basically you can write this as cos of, you can write it as negative 2 cos of phi minus theta. Phi minus theta. You can write it as negative 2 cos of phi minus theta. So to check again, basically sin phi sin theta plus cos phi cos theta is equal to basically cos of phi minus theta, and there's a negative 2 over here. Now you have this negative 2 over here, and there is another formula. There is another formula that I remember from here is okay, so over here you have, you see over here you have, there is a 2 over here as well. So you have negative 2 cos phi minus theta plus 2, right? So you can take the 2 out. You can take the 2 out, and then 1 minus, or you can take a negative 2 out. Let me figure this out. Okay, so this part is a little bit tricky, but I will explain it to you. You will of course understand it. So you see over here, I want to write basically this part. This part I want to write it as, I want to express it as this thing over here. 2 times the absolute value of sine of phi minus theta divided by 2. 2 times, I want to express it as 2 times the absolute, the denominator, 2 times the absolute value of sine phi minus theta divided by 2. Okay. Now in order to do that, what we have, I don't care about the numerator right now. The denominator is basically, as we said over here, was basically this thing over here, negative 2 times and there was a 2 over here, so I brought the 2 over here, and there is a square root function over here as well. You already know the square root function is over here, and so I erased these things from here so that you know that there is a square root function, and under the square root function we have this expression. And once this expression comes out of the square root function, it has to become this thing over here. Okay. So now you have basically negative 2 cos of phi minus theta plus 2. Now I don't really remember how I did this, but it must be right, hopefully. And it was right, because I got to the right answer actually, which is not a very good reason, but I'm sure that is correct. So I can take a 2 out from here, or I can take a negative 2. Forget about this part over here. I can take a negative 2 out from here, and so if I take a negative 2 out from here, I will get cos of phi minus theta minus 1. So minus 1 times minus 2 is equal to negative 2 times negative 1 is equal to positive 2. That would be negative 2 cos phi minus theta. So I take a negative 2 out from here, and write this as cos of phi minus theta negative 1, right? Negative 1. And there is a formula about there are basically all of these formulas in trigonometry, as you know, and if you have any problems with this, you can you can let me know. I will go and derive all of the trigonometry formulas for you. That would take some time, but it would be worth it if you basically didn't know how they were derived basically. So there is basically all of these angles, like the double angles, the triple angles, and so on and so forth. And we have, for example, some formulas, for example, for sine, for example, 2x, which is, for example, in terms of, for example, this would be 2 sine x, for example, cos x. There is other things over here as well. There is there is formulas for example for cos 2x, which is basically, for example, one thing that, for example, cos 2x, you can write it as, for example, cos squared x minus sine squared x, cos squared x minus sine squared x, or you can write it as 2 cos squared x minus 1, 2 cos squared x minus 1, and as you can see over here, I have 2x, and over here I have x, meaning that over here I get half the angle that I have over here. Or you can write it as 1 minus 2 times sine squared x, or you can write it as basically 1 minus tan squared x, 1 minus tan squared x over 1 plus tan squared x. So cos 2x, basically you can write it in these different forms. Now if I pick this form over here and bring it over here, what I can do is that basically cos of phi minus theta, if cos of 2x is equal to 1 minus 2 times sine squared x, then cos of phi minus theta, take this as 2x, and then over here you would get 1 minus 2 times sine of basically the same, half of the same angle, meaning that phi minus theta divided by 2, right? And so now instead of cos of phi minus theta, I can write 1 minus 2 times sine of phi minus theta divided by 2, sine squared phi minus theta divided by 2. So I can write this as negative 2 times basically 1 minus 2 times sine squared phi minus theta divided by 2, and you have a negative 1 over here, and that's it. Now these two you can cancel out, and then you can multiply these two, you get positive 4 sine squared phi minus theta divided by 2. Okay, so now if you put this under the square root function, 4 sine squared 4 times sine squared phi minus theta divided by 2. So that is basically what we were looking for. So what that means is that now I have this expression over here, and I can write this as the absolute value of sine of phi minus theta, and over here the square root of 4 is equal to 2, and the square root of sine squared phi minus theta divided by 2 is the absolute value of sine, not sine squared, but sine phi minus theta divided by 2. And I'm using the absolute value function just to make sure that sine of phi minus theta divided by 2 is not a negative value. And I have the absolute value function over here as well. And so that is basically the answer that we were looking for. We wanted to, I mean the right answer based on the book is basically this answer over here, which is the perpendicular distance from the origin to the line joining these 2 points. And the right answer according to the book is sine of basically phi minus theta over, and the absolute value of that over 2 times the absolute value of sine basically phi minus theta divided by 2. Okay, so that is the right answer, and that's basically what we got over here. So of course all of these are well useful, and you do need to know them. They are simple logic, and you don't really need to be I mean, you don't really need to think of mathematics as this big, vast, giant thing that it is. The good thing about mathematics is that of course it is this vast, giant thing, and as you keep going inside, there is no end, of course. But the good thing about that is that, and of course another good thing about that is that you can do it one step at a time with logical steps, and if you do that, you can always keep going and you will never be stopped. You will never be stopped as long as you take one basically logical step after another one and after another one, and then using this very simple, very simple strategy, you can do almost anything that is possible in mathematics. You can do it, irrespective of your educational background, irrespective of your IQ, irrespective of your circumstances or whatever, or other things which are probably related to this. So the next question that we have is question number 6, which we will do in the next video. I'll see you in the next video.